My dear students, I welcome you to today's lecture and I hope that you are all well. We are doing FSC Part 1 Mathematics Science Inter Part 1 and we are doing chapter number 9, Introduction to or the Fundamentals of Trigonometry. And we are doing exercise 9.2 and we have done some fundamental identities as well yesterday. I will write those fundamental identities first and then I will start doing the exercise. So there are three fundamental identities. Number one, sine square theta plus cosine square theta equals to 1. Right? It can be written as cosine square theta plus sine square theta is equal to 1, or it may be written as 1 equals to sine square theta plus cosine square theta. This is the first identity. Number 2 is 1 plus tangent square theta equals to secant square theta. Right? And it is true for every value of theta. Okay? Every or any value of theta. So this may be written as tangent square theta equals to secant square theta minus 1, or it may be written as secant square theta equals to 1 plus tangent square theta. And the last one, third one is 1 plus cotangent square theta equals to cosecant square theta. This is true for every value of theta. So these are the three identities, and now I'll do exercise 9.2. And I'm doing the short questions only, right? And I'm doing the short questions which appeared in the past papers. If you did not subscribe my channel, please subscribe it and press the bell icon button so that you may get the notification of newly uploaded videos in time. That's it. Okay, if sine theta equals to, okay, before doing this, I will do one more thing for you. Just wait, I will do one more thing for you. Right, suppose this is the coordinate system. Right. Right. Okay, so this is the quadrant 1. Let's say this is the quadrant 2. Right, let's say this is the quadrant 3, 4, and like this, okay? Right, and make all this, okay, for you. Right, okay. Now I will discuss, okay? Now you can easily see this is x, this is y, this is minus x, and this is minus y or y bar, okay? One and the same thing. So now let this side is small x, this side is y. This side is minus x now, this side is y. This side is minus x and this side is minus y. And this side is x and this side is y. So here we can see that, and this is r, suppose. So you can see that all values are positive here. So sine x equals to y over x, which is positive. Both are positive, okay? And cosine x is equal to, sorry, y over r. It is x over r, positive, and tangent x is equal to y over x. It is also positive. So all positive, we write it A. Here you can see that sine is a positive. So sine x equals to, this is the angle. So y is positive y over r. R is positive everywhere. Cosine x is equal to minus x over r. And tangent x is equal to y over minus x or minus this is. So only sine is positive here. AS. Here you can see that sine is minus y over r. Cosine is minus x over r. And tangent is minus y over minus x. This is positive. So only tangent is positive here. Similarly, cosine is positive here because cosine equals to x over r. This is minus y, this which is positive. So all positive, cosine positive, tangent positive, and sine positive. So these are the quadrants position. And now I am doing the question number 1. Question 1 is a short question. If sine theta is 1 over 2 with minus sign, right? The terminal ray is not in quadrant 3. So theta is not in quadrant 3. So sine is negative in quadrant 3 and quadrant 4. So therefore, we have to find cosine theta. But theta is in quadrant 4. Is that okay? Because sine is negative in 3 and 4. So theta is not in 3. So therefore, it might be in quadrant 4. So if it is in quadrant 4, so let's do what is it. So now using cosine square theta plus sine square theta equals to 1, or cosine square theta equals to 1 minus sine square theta, which is equals to 1 minus 1 over 2 root square. So cosine square theta equals to 1 minus 1 over 2 implies cosine square theta equals to 1 over 2 and cosine theta equals to 1 over 2 root. Right, it will carry the plus sign. So cosine theta will be plus 1 over 2 because theta lies in 4. Theta lies in quadrant 4. That's the answer. And these questions are repeatedly asked in the board exams. Right, 2. Tangent theta is equals to, tangent theta equals to 8 over 15 equals to 8 over 15. Right. And the terminal ray is not in 1. And theta lies in quadrant 3. Okay. Because it is not in the first quadrant, must be. Find the value of cosine theta and cosecant theta. So now find cosine theta. Cosine theta and cosecant theta. Okay. Right. So cotangent theta equals to this. It means that tangent theta is equal to this. Okay. So tangent square theta equals to secant square theta minus 1. Okay. So secant square theta equals to 1 plus tangent square theta, which is equals to 1 plus 8 over 15 square. So it means that secant square theta equals to 1 plus 64 over 225. So equals to 289 over 289 over 225. Or secant theta equals to 289 over 225. Right? So secant theta equals to, right, 17 over 15 implies cosine theta equals to 15 over 17 with minus sign because the radiant theta lies in third quadrant. Okay. Now come to the second thing. This is cosine theta. Now let's go for uh, cosecant theta. Now cosecant theta equals to cotangent theta divided by cosine theta, which is equals to by 8 over 15 divided by 15 over 17. Okay. Tangent is 15 over 8 rather, right? So 15 over 8 multiplied by 17 over 15. These two got cancelled. We left with cosecant theta equals to 17 over 8, but this will carry minus sign because theta in quadrant 3. I hope you understand it well. Right. The next question is very simple, straight. Okay. In which quadrant the terminal ray arm of the angle line? The terminal ray lie if sine theta is negative and cosine theta is positive. Now, sine theta is negative, sine theta negative means quadrant 3 or quadrant 4. And cosine theta is positive means quadrant 1 or quadrant 4. So quadrant 4 is common to both. Therefore, theta lies in quadrant 4. I hope you understand it well. Let's move to the next question. Okay, if sine theta equals to number 4, if sine theta equals to 12 over 13, find cosine theta and tangent theta. Okay. Theta. Okay. This is the question mark. Okay. Right. Sine theta is equal to 12 over 13. Cosine theta value and tangent theta's value. Right. Okay. So sine theta is equal to this. Now we know that the fundamental identity is cosine square theta plus sine square theta equals to 1, or cosine square theta equals to 1 minus sine square theta. Okay, clear? So is equals to 1 minus 12 over 13 the square, right? So equals to 1 minus 144 over 169. So when we do it, the sine theta equals to 25 over 13, sorry, yes, or cosine theta equals to plus minus 5 over 13, okay? Nothing is given, so we take it as the terminal ray is in the first quadrant, okay? So cosine theta equals to 5 over 13. Now we want to find the value of tangent theta. So tangent theta equals to sine theta divided by cosine theta equals to 12 over 13 divided by 5 over 13, okay? So which is equals to, so tangent theta equals to 12 over 13 multiplied by 13 over 5. 13 got cancelled, we left with 12 over 5. So both the values we have calculated, right? So this is all. I hope you understand it well. If there are some doubts, you may clear these doubts by sending me the message on the WhatsApp number given at the thumbnail of every video. So thank you very much. Thank you very much for joining. Thank you very much for subscribing. Thank you very much for watching my videos. So thank you very much. Allah aapka हामी nasir ho.